Hello to all of you, dear master students of the Faculty of Civil Engineering and Architecture. My name is Andrius Urelionis, and I will present to you an introduction to Research Project 1, a course joined by students from all civil engineering master programs. It is important that you understand how Research Project 1 fits into the overall master program structure and how your research competences will be developed during the upcoming 1.5 years. So welcome to the course. I would like to begin by exploring what sets apart a master's program from a bachelor's program. While bachelor's graduates are equipped with the skills to apply existing knowledge and methods, as a master's student you are supposed to solve problems and analyze systems that are much more complex and cutting edge in your field. As a master's student in civil engineering, you'll develop the ability to design new products, identify, formulate, and solve engineering problems, carry out simulations, laboratory tests, and draw conclusions. Formulate judgments with limited or incomplete information. Therefore, it is essential that you question existing practices. Think of ways how to improve them. It's important for you to be able to conduct investigations and simulations. You should also keep multidisciplinary context in mind and how your work in the field of civil engineering affects environment, safety of people, how the systems will interact and function. Therefore, in this course, you'll develop skills to apply research methods to solve engineering problems. You will learn how to formulate your research questions, conduct literature reviews, plan your research and design experiments, effectively report your findings, and moreover, you will learn how to ensure that your research is transparent and replicable so that someone can replicate it or work on it further. Finally, in this course, you will prepare research paper and poster and will learn how to present your work. Now, you might be thinking that these skills are important for scientists and researchers in academic environments. However, as an engineer, you'll face challenges that require you to analyze and make informed decisions. You'll evaluate which systems are superior and what design options to choose, even when faced with uncertainties. You might need to perform cost-benefit analysis, check good practice examples, search for literature to prove your point, or you even might end up working in a research and development group at your company, where your primary goal will be developing and testing new products. This is why research competences are so important to engineers. And here are some examples of areas where you might apply these competences. So the first one is design and development. Conducting research to gather information, analyze data, and explore different design options in order to create efficient and reliable engineering solutions. This is very important for an engineer. The second one is technological innovation. Researching emerging technologies, materials. You will either innovate yourself or you will have to navigate the innovation that will be constantly happening in your engineering field. And you will have to adapt to innovations and disruptions. The next one is problem solving and troubleshooting. Research plays a significant role in identifying the root causes of engineering problems, investigating potential solutions, and developing effective strategies for troubleshooting. Systems performance optimization. Engineers often need to conduct research to improve the performance and efficiency of existing systems or processes or products. This may involve studying designs, conducting experiments, and analyzing data to identify areas for improvement. It can be finding a new composition of concrete or optimizing energy performance of a building. Safety and risk assessment. Research is also necessary here to assess potential risks associated with engineering projects, develop safety protocols, and ensure compliance with relevant regulations and standards. And last but not least, environmental and sustainability assessment. You will have to explore sustainable practices, analyze and research solutions to minimize the environmental impact of your projects, for example, CO2 footprint. So this is what the forward-thinking industry and respected companies will be expecting of you as a master's graduate. And Kaunas University of Technology has developed a path for you to help you to achieve these goals. Research Project 1 is a course that engages you in a team-based environment, guiding you through the entire research process, from problem identification, literature review, to research planning, experiments and simulations. Additionally, you will learn how to effectively present your findings through various mediums, including quick pitches, papers and posters. Considering that this may be your first experience with such a research project, we emphasize the importance of teamwork. Your backgrounds and experience may be different, so during your first research project, you can learn from each other, utilize everyone's strengths. Within October-November, you will choose the topic of your master's project and will be assigned a supervisor. Therefore, in Research Project 2, you will start working on your own research. You will learn more about research methods applied in civil engineering. You will be able to interact with invited speakers from companies that carry out research, development, and innovation. You will be consulting with your supervisor and will apply what you have learned in Research Project 1 for your particular project. The main goal of Research Project 2 is to guide you through the process of developing research design for your master's project, as well as for you to carry out literature review and first experiments or simulations. So at the end of Research Project 2, you should have a clear vision of your master's work and what needs to be done in the third semester. And lastly, you will have the opportunity to apply all the skills you have acquired in your master's degree final project. This pivotal stage allows you to conduct the majority of your experiments and compose your thesis. In conclusion, I hope that you have a better understanding of what research in engineering involves. The skills you will acquire through research will be useful to you in various aspects, such as selecting optimal design solutions, improving systems, and many more. I encourage you to approach this journey with an open mind, curiosity, and willingness to ask questions, engage in discussions, challenge conventional practices, and contribute to creating a more sustainable and better built environment. You may be surprised with the results you get, but that's also a part of the experience. Once again, I extend a warm welcome to the Civil Engineering Master's Program at KTU. Good luck with your studies and your research.